Hello guys, welcome back to another video. In this video we will consider an integral from 0 to 1 ln of 1 plus x divided by x dx. Alright, we will try to solve this integral and find it in terms of a value, not in terms of a special function or something. So we don't want something like polylogarithm or something like that. We want the concrete value for this. All right. The first thing we will do, we will expand the logarithm, the natural logarithm, into x minus x squared over 2 plus x to the third divided by 3 minus x to the fourth divided by 4 and so on divided by x dx. And I will change my marker right now because why not? You know, it's just the alternating sum of x to the n and then just the alternating sum. All right. So what happens when we do this? We get 1 minus x over 2 plus x over 2 by 3 minus x over 3 by 4 and so on dx. All right. Which equals, when we integrate this term by term, we get 1 minus 1 half squared plus 1 divided by 3 squared, minus, not plus, minus 1 divided by 4 squared plus 1 divided by 5 squared, and so on. All right, how can we actually find a value for something like this? Well, let me show you. This looks like a sum 1 over n squared, which is a famous sum which equals to pi squared over 6. Just the terms are a bit mixed up, and I will show you how to do this problem. We will consider a sum 1 over n squared to be equal to pi squared over 6. I won't derive this in this video because the video would probably get too long, and so we will use this, and let's continue with our problem. Yeah, we will split this sum into a sum of even and odd terms. 1 over n squared is the sum of 2n squared plus a sum of 1 divided by 2n minus 1 squared. Every sum can be split up into a sum of odd and a sum of even numbers. All right, when we say this, for this one we know the value. It's pi squared over 6. Yeah, it's nothing new. Pi squared over 6. This is 1 over 4 and n squared. So this is basically the same, just with 1 over 4. Pi squared over 6, yeah? We know this. And let's call this one x. An alternating, not an alternating, but an odd part of this sum. Let's call it x. And so I just solve for x right now, nothing special. X equals pi squared over 6 minus pi squared over 24, which equals to 24. This is 4 times, yeah. 4 minus 1 is 3 over 24. Yeah, and this is what? 1 over 8, but pi squared, yeah. And so we got this. So what did we actually found? We found that the odd parts of 1 over n squared is pi squared over 8. So why did we actually need this? If we take a closer look at our problem, we have 1 minus 1 divided by 2 squared. I mean, we can write this as 1 squared. I mean, yeah, you can write this as 1 squared, 1 divided by 1 squared, and we get this. So as you can see, it's a difference between the odd and even parts. So that's why we needed this. Let me just erase all of this and remember the crucial things. This is equal to this, and we already know this one. I mean, and the even part, I mean 1 over 4n squared, we already know it's pi squared over 24. How do we know this? Because from here, we got it from here. So let me just erase all of this, because we really don't need this. We will need more space. And so I'm going to erase this too. And what happens now? There's magic. This one is a difference between the odd part and the even part of the 1 over n squared. So let's just subtract those two. This one is an odd part of 1 over n squared as we calculated, and this one is an even part. So we know what we have to do. Pi squared over 8 minus, okay, this 8 looks weird, 8 minus pi squared over 24, and we shall get a result. 24 is the common one, 3 here, minus 1 pi squared, 2 divided by 24 pi squared, and this one equals 0. Okay, I'm joking. Pi squared over 12. Yeah. So our problem ends up being this. All right. So yeah. Let me just say this. In the next videos, I'm gonna use this result. If someone asks, okay, I'm gonna use this result. If you have, which result? This one. The odd part of 1 over n squared is pi squared over 8. I will use that in the future videos to solve some tricky integrals which you will find interesting. Just so you know, I won't derive it 100 times in every single video. Like, if just so you know, if you need to remember how do you derive this, just click on this video. On the next video I will post. Alright, that was it for this video. Like, share and subscribe if you want to see more of this. And what? See you in the next video. Bye guys.